Okay, I'm going to review transformation of functions. We talked about this in class today, and I just want to kind of recap. So, transformation of functions deals with horizontal shift, vertical shift, and stretching and shrinking. So, let's get started. Let's see what all of these things look like. So, let's take a look at y equals x squared. We know what that parent graph looks like. That's just a parabola, like that. Vertex at 0, 0. So what happens when we have y equals x squared plus 3? Well, that's just shifted 3 units up. So now my vertex is at 0, 3. Same thing, same width, same everything, except it's moved up 3 units. And x minus 3, well, the minus is telling me that it's vertically shifted but down 3 units. So again, instead of at 0, 0, it's at 0, negative 3. And that's what a vertical shift is. So you're expected to know that if you see a function, and here's the original function, we call the original function the parent graph, you're expected to know that if a number is being added or subtracted, that it's a vertical shift up or down. And that's vertical shift. Let's take a look at horizontal shift. Okay, let's compare y equals x squared with y equals x plus 3 quantity squared. Notice I'm still using a positive 3. I'm still using a plus 3 in my function, but notice the location. The location is different. This time it's inside the parentheses, not outside. On the vertical shift, it was on the outside like that. This time the positive 3 is in the inside. That changes the graph dramatically. Again, whoops, here's the parent graph. The original function, y equals x squared, right? That's this one. And let me just change colors here. And y equals x plus 3 quantity squared. That's just shifted. And remember, this says, the plus 3 says we are moving in the opposite direction. We are moving in this direction. You have to remember that. For horizontal shift, it's the opposite sign. So x plus 3 means I'm moving 3 in the negative direction. So now, instead of having a vertex of 0, 0, I'm starting here at negative 3, 0. And that's my function. Same thing. Let me just clear this slide here. Same thing if I had y equals x minus 3. Whoops. Minus 3 squared. So what's that look like? Again, I'll start with the original one, y equals x squared. There's the original one. And minus 3 means I'm going in the positive direction, I'm going in the opposite direction. Okay, so this minus is saying it's the opposite, so I'm going to go in the plus 3 direction. So let's say plus 3 is right here, and I just moved it. So there's a horizontal shift. Now let's take a look at stretches and shrinking. Okay, let's take a look at this first graph right here, y equals x squared. And I have two similar graphs, right? Same, labeled the same way. So at 0, it's 0. Let me just change colors here. Okay. So at 0, it's 0. If let's see, at 1, it's 1 squared is 1, so we'll put that right here. At negative 1, it's also 1, so let's say right here. Whoop. Right there. At 2, it's 4. At negative 2, it's 4. And here's my parabola. And we know, of course, it goes on to positive and negative infinity, the domain. Let's take a look at 2x squared. What happens when we multiply it by a number? What happens when we multiply it? In this case, by 2. Okay, let me change colors here. Let's see. So at 0, it's still 0. At 1, 1 squared is 1 times 2 is 2. So at 1, it's 2. And at negative 1, it's also 2. At 2, well, 2 squared is 4, and 4 times 2 is 8. So at 2, it goes all the way up to 8. So you can see it's a sharper curve. And at negative 2, it's also 8. And as you can see, it's similar, but it's narrower. Okay? So a transformation did take place. Let's take a look when I multiply it by 1/2 instead of by 2. What happens there? Okay, let's erase this. So I'm going to try and do the same scale so you guys can see the difference. 1, 2, 2. I'll still count by 2s just so you can kind of see. 2, 4, 1, 2, 3, 1, whoop, 1, 2, 3. And what happens when it's y equals 1/2 x squared? Okay. So let's see, at 0, it's still 0. At 1, 1 squared is 1. 1 times 1/2 is 1/2, so 1/2 is right here. Whoops. At -1, it's also positive 1/2. Let's take a look at 2. What happens at 2? So 2 squared is 4, and half of 4 is 2. So at 2, it's 2. And at -2, it's 2. And what happens at 3? 3 squared is 9, and 9 times 1/2 is 4.5. So we can say right about here. Oh. And notice here, it's wider. So we can conclude that when the factor in front of x squared is a fraction less than 1, that it's going to make the parabola wider. And when the factor in front of x squared is greater than 1, the absolute value of that is greater than 1, it's going to make it narrower. There's one more thing we want to look at, and that is reflections. And so if I had y equals -x squared, what does that look like? Almost identical to the parent graph, except, whoops, it's reflected. And you can test out some points. At 0, it's 0. At 1, what's 1 squared? 1 squared is 1, and then you want to apply that negative. That's almost as if there's a -1 out here, right? Order of operations say we square first, then multiply by -1. So at 1, it's -1, and at -1, it's still -1. Let's see, if I plug in 2 for x, well, 2 squared is 4, and 4 times -1 is -4. So as you can see, my y values are all going to be negative. So just to kind of conclude for your notes, of an example of a horizontal shift. Whoops. And by the way, this will work for any function, would be y equals x squared plus 3. That's 3 units. I'm moving the parabola 3 units up. Y equals x squared minus 3. Oh, not horizontal shift, I'm sorry, vertical shift. Whoop, let me erase that. Plus 3 is I'm moving the parabola up 3 units, -3 I'm moving it down. Horizontal shift is when that 3 or any number is in the parentheses. So y equals x plus 3 squared. The parabola is moving 3 units in the negative direction, and y equals x minus 3 squared, and that parabola is moving 3 units in the positive direction. So I hope you found this helpful. Bye-bye.